I would like to start by thanking you all so much for logging on today and joining us. We really appreciate your participation and hope you're all well. My name is Vanessa Scott, and I work in industry relations and innovation here at Scripps Institution of Oceanography, UC San Diego, and I will be your moderator today. We're really excited to present our new Scripps Innovation webinar, which is the first of 2022, and it's hosted by the Scripps Corporate Alliance. Just a little bit of background about Scripps. We're a division of UC San Diego, originally founded in 1903. We have about 2,000 students, researchers, volunteers, and staff in our community. We produce about 700 research publications a year and receive approximately $214 million in sponsored research annually. And our mission at Scripps Oceanography is to understand and protect the planet and investigate the oceans, earth, and atmosphere to find solutions to our greatest environmental challenges. So this webinar series will focus on two of our main research initiatives, which you can see all of our big priorities here. The first being risk and resilience to hazards, and the second being human health in the ocean. Both occur quarterly, so stay tuned for upcoming webinars. You can check them on our website, and you can also view past recordings on our website as well, which we'll drop in the chat. And the goal of this webinar series is really to inform our industry partners of our latest research and innovation, applied research tools, and ways to collaborate with our scientists and community to find mutually beneficial solutions. Just some quick housekeeping items. This will be recorded and available afterwards on our website. So please feel free to distribute to your colleagues as you see fit. Also, you can find the Q&A button on the bottom center of your screen. Please feel free to enter your questions throughout the presentation. We will hold them till the end, but we encourage a lot of participation. We want this to be an interactive discussion. You can always communicate with us through the chat as well. And even if you want to be unmuted, you can raise your hand and we'll see about unmuting you as well. So if we're unable for some reason to get to all of your questions during the webinar, we'll make sure we follow up with you after. Next slide, please. And with that, I'm really excited to introduce our speaker today, Steve Diggs, who is the Technical Director of the Hydrographic Data Group here at Scripps Institution of Oceanography. Steve got his start as an undergraduate engineering assistant in the 1980s, and after spending a decade working as a DoD contractor, he returned to Scripps as a field data specialist and ended up working with instruments and software for PIs in nearly every science domain at Scripps and NOAA. His 30-year career has evolved into the design and maintenance of geoscience data resources. In addition to his work here at Scripps, he was recently elected to the United Nations Ocean Decade Data Coordination Task Group. He also teaches data best practices through his work with the International Science Council, and he reviews data systems and projects for the National Science Foundation. And with that, I will hand it over to you, Steve.
Thanks, Vanessa. You just stole all my best material. Good afternoon, good morning, good evening, whatever time of day it is in your time zone. Thanks for giving up your precious time and getting on yet another telepresence meeting. I know it's not easy, and we'll do our best to keep you engaged and to answer your questions. So the main point of the presentation today and the discussion will be the data at Scripps. Data at Scripps is not just Scripps produced, but data at Scripps, like many other scientific enterprises, is a collaboration of many institutions, but many of the initiatives and instrumentation were built or started here. I want to start you off with a story when we're talking about using data as a strategic advantage. Who has more strategy than the military, especially during World War II? If you're familiar with Scripps, you know about Walter Monk. He was a meteorologist at one point before he got his PhD in North Carolina, and he was observing the landings for that they were practicing in North Carolina for Northwest Africa, and then he looked at the literature about the waves in Northwest Africa, and he said, this is going to be a catastrophe. And he couldn't let go of it, so he got in touch with Harold Sverdrup, who was the director of Scripps at the time, and they worked together pretty diligently. And then the Sverdrup-Monk wave prediction method helped the Allied forces predict the waves in their landings and saved countless lives. So there's a direct application of research done at Scripps, research and the data that's used as a strategic advantage in enterprise. And then in this case, the enterprise is the US military. So when I was thinking about this topic in terms broadly in terms of Scripps and data, I keep going back to Walter Monk. He helped me out a lot as an undergrad, as Vanessa mentioned, when I first came to Scripps. And one of his quotes is that the 20th century was the century of undersampling the ocean. It was very opportunistic. Wherever the ships went was where we could sample, not exploring and sampling where we needed to be. But I'm also kind of a fan of John Naisbitt. He had a little checkered past, but one of his statements that I've adapted here: we're drowning in information or data, but we're really starved for knowledge, meaning we have all this information around us, but can't we make sense of it? And more to the point, can we repurpose it? If you look at Scripps as a glance, we're a pretty impressive team. Between the personnel on the left, between the volunteers, the faculty, research, staff, and the students, which numbers just over 16 or 1700, and then revenue at about $250 million. So we're not under-resourced in terms of the tasks and exploration that we take on. And there are some pretty impressive things, at least in my brief history with Scripps, that I'd like to talk to you about. So Scripps seems to be everywhere. This is a map just from 2018 of the voyages that Scripps was on. Now, we don't want to limit our discussion to Scripps to just ships, because we know it's more than ships, but you get a good feeling geographically in this Mercator projection map where the Scripps ships went in 2018. Scripps does just about everything that I could find. If you look at these two diagrams, you can see these process studies and programs that we're involved in. Some involve ice sheets, many involved spacecraft, aircraft, surface measurements, subsurface measurements, crustal deformation. I went through and found as many topics of Scripps research that weren't the ones you expect: acoustic thermometry and ocean bathymetry, petrology, all kinds of seismic activity, tides, turbulence, volcanoes, you name it. I think except for land animals, which we don't really specialize in, it's everything else. So when we talk about data at Scripps, we're really talking about data and expertise. Those two things are inseparable. So you don't just get an Excel data set and you go off and use it, but usually there's an expert who is either taking those measurements, who has expertise with those measurements, can help you make sense, turn that data into information, and subsequently into knowledge. A few examples of long-running data collection programs that are here at Scripps. So the shore station, everybody sees the pier when they come to San Diego. It's a pretty iconic. And I advise all of you, if you're in the San Diego area, you know, we have a little offshore wind, go down and take in the sunset by the pier today. So it started in 1916. We're running well over 100 years of continuous daily samples of sea surface temperature and salinity. You'll see there, one of the people sampling will probably analyze it for what bugs are in the water. And it's one of the world's longest ocean time series, certainly the longest on the Pacific Rim. And those data are available on the Scripps website. A word about the harmful algal blooms. So if you're in Southern California, every now and then we get these harmful algal blooms with neurotoxins, the red tide. I worked with George Shigahara briefly, putting together some proposals, and became aware of this data collection and analysis with nonlinear methods. And the upshot of it was that they found that the conditions that seemed to be random that led up to these harmful algal blooms actually had a pattern. So how valuable is it to know 3 weeks in advance if there's going to be a harmful algal bloom if you're in recreation, or any one of the other industries that depends on people going into the water along the coastal region. And of course, we have the iconic Keeling curve that's been going on since 1952. It's considered the foundation of the modern climate change information source, and it's still going on. I know that Ralph Keeling is keeping that program running. And again, those data are available at Scripps, and it's actually a pretty small data set. that's pretty easy to understand. So those are kind of the usual suspects of data collection and data programs that are here at Scripps. But let's take a deeper dive and go into two programs that I'm somewhat familiar with. The first one's CDIP, or the Coastal Data Information Program. Now, the obvious one that I'm not going to mention here is the Surfline, or the surfing website that many people who go in the water use, but some other applications of these data. So the Coastal Data Information Program, they measure and analyze and disseminate coastal information with over 67 active water stations, wave stations, 294 stations deployed since 75. So it's been going on for a little bit. They have between 16 and 20 people, I think, now working there. And then the major funding comes from U.S. Army Corps of Engineers, the partner with the state of California. And there's 8.5 million page views, but way more than that are the people that access the data directly. And their mission is to provide a high quality observations for research or operations. So how are these data being used in industry, or what are the strategic advantages that can be gained from CDIP knowledge? Here you see kind of a synoptic map of where these stations are. They're all over the Pacific Rim, up to and in Alaska, in the Gulf region. And in the center is one of the buoys with the phone number on it. In case you're out at sea and you happen to have a phone on you, you can say that the buoy is doing just fine. It's a pretty robust system and a very, very well thought out website. If you want to go, it is cdip.ucsd.edu, and you can go into each one of the CDIP buoys, click on it, and get an analysis page and download the data. On the right, you can see how robust their system is. They have 3 different ways that they get wave data back: through Iridium, which is a much more real-time system. They have an HF radio transmission, and then they routinely go out and get the data logger and recover a compact flash. Those data are stored at the CDIP data centers you can see on the right, which is in a continuously managed, power managed, rack-mounted facility. Okay, so some of the strategic advantages that I was able to find of how there's partnership or just active users. Now, remember, these data are freely available. However, there are some industry partners that contribute to keep certain instrumentation in the water that serves part of their interest. So there's a good mix between the data that are funded and ongoing, and then specific enhancements to the network that serve particular people. So we have the Diablo Canyon buoy, public utility. I did not know this, but the kelp breaks loose and clogs the intake filters for the facilities. And if they do, they have to shut it down. It's nice to know if they can anticipate this. Then there's the Long Beach Channel, where the ships come in. I think that everyone is pretty sensitive to supply chain issues, and you would love to know if oil tankers are going to come in with their 9-inch clearance on a 1,000-foot tanker. It's going to be pretty important to know what the wave activity looks like. The Santa Monica buoy, right up by LAX, which supplies a significant percentage of the fuel for LAX, and they monitor that for all of their activities up there. And then, of course, one that may take you by surprise, that some of the buoys that the data goes into NDBC, the National Data Buoy Center run by NOAA, which CDIP is a partner of, provides that information to NASA and other private companies that are putting platforms and instruments into space. So those are some example uses of these free data that are produced by a Scripps entity, and how these various enterprises are taking advantage of it strategically. You can't really mention Scripps these days without thinking about Argos or robots in the ocean. Very fascinating program. Major development took place here at Scripps, and Argo floats are being built here daily. So if you don't know about the Argo Global Away, it started about 23 years ago during WOS, the World Ocean Circulation, and now has over 4,000 floats in the ocean. And you can see that we're getting measurements all at the same time on these 10-day missions. The original core design was for 3 degree by 3 degree spacing in ice-free zones between 60 north and 60 south, and down to about 2,000 meters in the ocean. When these instruments come up, as I'll show in a minute, they do a profile on temperature and salinity for the core Argo, and that's being expanded. So this is the basic float design. As you can see, this instrument's able to vary its buoyancy, so it's able to sink in the water column and come back up. You see there's a satellite antenna on the top, and much like the CDIP buoys, it communicates through a variety of network satellite systems, the most common now being Iridium, which is high bandwidth, and it has a CTD on board, so it gives back pressure, temperature, and salinity on these 10-day missions. This is a basic schematic of what it looks like on a float once they're deployed and they go into water. They sink down to about 1,000 meters. They drift for roughly 10 days on a standard mission. When they're ready to profile, they'll sink down to about 2,000 meters, or in the case of deep Argo, which I'll talk about in a moment, they go to about 6,000 meters. And on the way up, they're sampling temperature and salinity, much like many of the programs do with ship-based, with Rosette-based systems that have CTDs on them. At the top, they'll transmit their data. The data come back, and it goes into 2 systems. One is more real-time, and the other one is delayed mode for higher quality and climate studies. And then they'll sink back down and repeat that procedure. The number of days and the depth they sink to will vary depending on the mission, but this is one of the more standard mission profiles. So the impact that Argo has had on climate studies, so it has reduced the subsurface errors in temperature and salinity between 0 and 2,000 meters. We have a lot of measurement near the sea surface, and so there's less of an effect there. But as you go down the water column, there are less and less measurements geographically, and so the contribution of Argo really shines. And you can tell if you go to Ocean Sciences, many of the scientific papers are based on the Argo data, which is freely available and on multiple websites on both sides of the world. They're called GDACs, the Global Data Analysis Centers, Data Access Centers, and yeah, you can see that there is a much more accurate picture of the subsurface, the interior of the ocean, due to Argo. A couple of ways that Argo is being used in the IPCC, the Intergovernmental Panel on Climate Change, when they talk about the amount of warming that happens on Earth, it's mostly in the ocean. About 90% of the energy that is accumulated is in the ocean. And then the second statement has to do with the contribution of the Argo array, which is rather significant. And I think that that's an understatement. Now, remember, there are over 2 million profiles with over 4,000 floats. And this is such a great program and a platform that they're starting to go deeper and to go broader in terms of what can be measured in terms, including chlorophyll, dissolved organic matter, as well as pH and alkalinity. So, and then you see on the right, that thing in the hard hat, the yellow device being lowered or coming out of the water. I can't quite tell. Set a record diving depth in the Puerto Rico Trench of about 6,000 meters. Not a lot of the ocean is that deep, so that's covering a lot of the territory that is traditionally covered by ship-based instrumentation. So you're getting all of these measurements all the time, and many measurements that are available for free as soon as they're measured. So let's return to this concept of drowning in data. Now, if we have too much data that's uncurated, we don't get the information and subsequently the knowledge that we need out of it. So I want to talk a little bit more about more than just getting raw data, running off and doing analysis and having that be your strategic advantage, is coupling that with the expertise that's here at Scripps. So that is not me as a child. That is some other stock photo of a kid getting help from a reference librarian who's obviously helped this kid speed along in whatever scientific report he has to do. Um, for me, the reference librarian was everything. I was educated before the internet, and I needed some way to speed my way through all of the holdings in any given library. And I found the reference librarian both when I was coming up and when I came to UCSD, they were invaluable. The same holds true with data expertise. You need some way of locating the data, the right data that's fit for your use, and then having a knowledge base on how to use those data, up to and including code to analyze the data themselves. A few years ago, there was all of this talk about data being the new oil and data analysts and data scientists being the refinery. And after a few years of people sort of drowning and wallowing around in data, there was an article in Forbes last summer in a current movement in a lot of popular thinking, whereas we need more authoritative and filtered data and trustworthy sources. It's the highly filtered data that will lead us to quicker and smarter decisions. So I think in every enterprise, you want to be able to get to quicker and smarter decisions without first of all, being wrong, having the accurate outcome, but also putting less time, needless time into the analysis. So I'm going to leave you with this statement. I found this to be very, very true, working on multiple expeditions and process studies, is that these hypotheses do come and go, but the data remain and are reanalyzed. They end up being people's legacy and their pedigree. So, the data that's produced here at Scripps in conjunction with many of our partners, I don't think that we've tapped the true value of it for mankind. And I'd welcome to have a discussion about it for the balance of the time in this webinar. All right, I'm going to hand it back over to Vanessa.
Great. Thank you for that great presentation, Steve. And thank you all. Please feel free to enter your questions in the Q&A in the icon in the bottom center of your screen. I also do have a poll ready to go that we'd love to learn from you guys. Which data set, especially the ones that Steve covered, would be most applicable and of interest to your industry? So this is the first time I am launching one of these, so I'm launching it now. Please feel free to select which one you think would be most applicable. And we really want to use this time to learn more about how, if any, you would like to use Scripps data, or what data sets would be most of interest to you in your industry. So feel free to enter that into the Q&A. And looks like we got the poll going. Oh, it's looking kind of close. Looks like a pretty good tie between Coastal Data Information Program and Argo as of now, but we have about half of the people that have completed the poll. All right, well, we're waiting for the rest there. We've got a question submitted from John here asking, does Scripps have any data sets for environmental DNA? Great question, John.
All right, I'm going to go ahead and give a very qualified answer. Not that is ready for public dissemination, but we do have partners. So I'm at a repository. One of our partners is HUI with the Biological and Chemical Oceanographic Data Management Office, BICO-DEMO. And what we do is we will work to find which expedition environmental DNA data was taken, and we will locate the data sets themselves. And then we have a question from Mohan. Mm-hmm. Thank you for the compliment. How is international research collaboration? How international research collaboration is possible? I'm not sure I understand the question. If you're saying that during the pandemic, how is this international research coordinated and collaborated? I mean, a lot of it is done on the internet. Certainly, even pre-pandemic, we had a lot of international cooperation that was via telepresence. But I think that's part of a long-running tradition that Scripps has had with having our reputation and name out there and the connections that we have through some of our more esteemed colleagues. Yeah, if you want to add some detail to your question, I would be happy to continue to discuss this. And I'm going to move on to, yeah, that's great. All right, I'm going between chat and the Q&A. No, that's all right. This is how this goes. Some of the major challenges you foresee and face in the future when it comes to collection and analysis of these data. I know technology helps, but it can also hinder too. And in particular, even more information to dig through and put into context. So I think one of the best ways that Scripps data sets become valuable is because they go through rigorous scientific vetting, both in the refereed journals where people publish and having other people analyze the data. For instance, my data office, the one I work in, is deep hydrography. These data are routinely archived at the National Center for Environmental Information, NOAA's data archive, which used to be NODC, and then they're reused in lots of analysis. So we as a data office get that information back when people use the data. They may find something, there's a sensor drift, or maybe a method wasn't followed as tightly and they have some questions about the data. We'll reintroduce that information into the data file so subsequent use of the data is more informed. So that helps quite a bit. With Argo having so many near real-time measurements, again, it's the community use that makes the data valuable. But Argo also has a data management team, which is constantly looking at the data. And then there's a delayed mode analysis that also matches the profiles against more gold standard profiles that are taken on ships to ensure that the data, that the sensors aren't drifting on those robots. Let's see, we got lots of questions here. Wow.
Yeah, Steve, I've got,
Great.
yeah, in the chat, in the Q&A, I'm happy to moderate too, if that makes it a little bit easier for you.
Sure. I'm going to go to Chris's question on what kind of tools are commonly used to archive and visualize and process data. Are there any new ones on the horizon? So there's the usual suspects. We have for oceanographic data, there's Java Ocean Atlas and Ocean Data View. They're routinely used for if data are in NetCDF, if you know what that is. NASA has an excellent tool called Panoply that's free to use. There is another one that comes out of Lamont, and the name escapes me right now. But these are all packages that you can download for free. They're multi-platform, Linux, Mac OS, and Windows, and you can ingest most of the more popular data sets in them and begin analyzing them right away. There is a growing interest in a number of notebooks that are out there to analyze various data sources. And I know that these notebooks are both in Python and in R. In addition, there are some pretty popular GitHub repositories that point to not only GitHub R, I think some are in Rust as well as, and I'm leaving something out, MATLAB it would be the other one. So those are the tools that I know. Most of what I do is oceanographic and then atmospheric, and to a much lesser extent, solid earth physics, but those would be the analytical tools. And then Nathan Wynn asks, can we really explain how Argo collects data in response to climate change? So the Argo footprint was designed to be originally from 60 south to 60 north, and deployed by ships, planes, and other methods all over the world. They travel on the subsurface currents, and then they surface at various places. You can see by the dots on the map if you go back to the Argo map or look it up on the web. And it should give you a pretty good global coverage between no matter what the season is of what's going on in the upper 2,000 meters of the ocean. So that is how Argo collects data. Now that is an improvement over the sort of opportunistic measurements that we have with research vessels that go out to observe a phenomena or to reoccupy a survey that was done before. It only measures along that line. It will be able to measure more and more accurately still to this day, but it's not going to give you the global coverage. For instance, we're missing a lot of information during the pandemic in the Indian Ocean. Didn't have the number of ships globally that were out there. And so there will be this gaping hole of information for the very deep ocean in the Indian Ocean and in the Southern Ocean. Thank goodness we have Argo out there. All the Argo floats, thousands of floats out there in, between the Atlantic and the Pacific and the Indian Ocean, taking lots of measurements every 10 days. I hope that answered your question, Nathan. How is it possible to incorporate eDNA data in the Argos? You mentioned dissolved organic matter. Katrina, I don't think that they're taking eDNA data. Lab on a chip is pretty good, but not that good, to my knowledge. So I'm going to try to stay in my lane as much as possible. But to my knowledge, the eDNA data that's coming out of the ocean, again, to my awareness, is only with the discrete bottle samples that are coming out, and intense analysis both on the ship and on shore. Let's see. I almost answered Vanessa's question. You asked a question, and I was like, I know Vanessa Scott. That sounds very, very familiar.
I think
Okay.
next question. You want me to read that off?
All right, Katrina. How is it possible? I answered your. Hopefully, I answered your question. If I didn't, please ask more questions. What applications have you seen for this data for the energy industry? What are the key value offerings for energy industry? Is it safety, energy output forecasting, planning for new installations? Where I have seen data like CDIP and Argo and weather forecasting used has been safety. In terms of, whether there is a drill platform that's going to get hammered for their operational forecasting. Those have been the big things for the energy sector, but there are many, many other. I know that the Institute for Geophysics and Planetary Physics at Scripps has, dozens. I would believe dozens of researchers who are into paleomagnetism and subsurface crustal deformation, lots of different things. And I know that BP and other industries have tapped into the knowledge here at Scripps. So the data that I talked about, the oceanographic data, may have more safety applications, but in terms of oil exploration, I think that there are much better experts at Scripps who can tell you with their expertise and experience how their instrumentation and how their knowledge can be used. Research student exchange, capacity building program, data assimilation for numerical model, postdoctoral research opportunity, collaborative research. I'm going to go back to Mohan's earlier question. Let's see. I'm not sure, Mohan, I understand. I lost the thread on your original question. I think it went over to answered, so I'm going to jump over and see if I can answer that.
It was about international.
International collaboration. Okay, I got it. Research student exchange, I think the Scripps department has a much better handle on that. I have very little to do until students have a problem finding data, and then I get very involved in their research life. I think it would be the same with capacity building. Data assimilation for numerical models. So I think that almost all, if I limit my discussion to oceanographic data, almost all those data sets that are out there that are flagged in QC and the methods are known are fit for purpose for lots of numerical modeling, initiating models, correcting models. And then, yeah, postdoctoral research activity. Again, I'm going to, I think, Vanessa, do we have a link to the Scripps department?
I'm just going to drop that link in the chat right now.
Thank you. Yeah, so Mohan, just look in the chat for, there you go. Wayne, how long does an Argo buoy last between battery charges? Well, they go out with batteries, and when they die, they die. At last check, depending on how often they're cycled, I believe that the lifespan is 3 to 5 years. When the surface time was longer, I know that they didn't last as long as they took a lot of physical abuse. How many buoys have to be replaced annually to keep 3,000 to 4,000 buoys active? That is a really good question. I think that the number that I had seen before was ranging from 3 to 500 buoys. Obviously, during the pandemic, there were less ships at sea, so that is a concern with an aging Argo array. But we're seeing some floats that actually last longer than the stated time. There are some that, of course, last shorter. I mean, that's how averages work. Are the floats recyclable? Some have washed ashore. Some have been found. To my knowledge, I don't think that they're repurposed, but I do know that the environmental impact is minimal. And there is on the Argo website, there is a really good treatment of the environmental impact of Argo itself. And Philemon, hey Philemon, what is your protocol if an observing float or glider gets to another country's EEZ? Well, that's an interesting question. I am going to refer you to the GOMO office, GOMO at NOAA, and my colleague Emily Smith, who's over the Argo program. There was a time that if a float that was taking data that could have anything to do with fish hauls, that country could ask the array to shut down entirely. I don't know what the upshot was, but I do know that situation is better now, that the floats are seen on a more individual basis rather than it's just this global observing program that's either on or off. But any of those types of questions should be directed to the NOAA GOMO office, because they're the people that do all the operational aspects of Argo. Scripps and other research institutions are into the analysis of the data and deployment and design of floats. Do many data collection systems, go ahead, Vanessa, sorry.
Oh, no, I was just going to say, I see some in the chat too. I'm happy to read off if that's helpful.
I think I answered Chris's question. Chris Ward, if you didn't get.
There's some others. John asked another question. Do many data collection systems process data at the edge, like the sensor, or does the raw data always get processed ashore?
So for the systems that I'm familiar with, a lot of the data are processed at sea. For the ship-based sensors, lots of data are processed at sea. For some of the samples that are harder to analyze, they are brought back to shore. I don't know as much. When I was working in atmospheric science, a lot of those data were also analyzed in the field directly, except for things like dropsondes, where they would radio back the data, and sometimes it would go to a data center, and other times there'd be instruments that would need to be recovered. Yeah, so John, I think we would have to have a more focused discussion on which sensors, because it does vary. There are a lot of things where the data are taken in on an SD card or on some other recording device, and then they're analyzed either back in the lab or at sea in a delayed mode.
I see one more.
Kirk said, what is the quality of our subsurface ocean current data? Well, that's a very interesting question. The quality, I'm not sure I can answer the quality, but there is more subsurface ocean current data. So there's a couple of researchers I know that deal with the ocean currents, Uwe Zend, Matthew Alford, and a couple of others. There are more instruments out there, and the instruments are a lot more accurate than they used to be. That is certainly sure for the time series. I didn't talk about that in this webinar, but there are a number of time series programs that have a great deal of subsurface ocean current data. There are other ways to get at ocean currents. I know through the trajectory files with Argo, so they do travel on subsurface currents at 1,000 meters, and those data are being analyzed. And I believe that there is an ocean current forecasting system called Oscar, where they're using many of the traditional data to initialize those systems. And there's a nice website that I will make available in the chat where you can actually visualize these global subsurface or surface currents, not subsurface. Reference librarians, yeah, I mean, you bet. Reference librarians are everything. Any more questions? What I would love to see as well from those who are still here, Scripps takes a lot of data. I think I had a slide that I'm going to go back to before we get to the results of the poll. And we talked a little bit about all the other data types at Scripps. These are sort of the things, the non-usual suspects of areas of research. There's obviously someone brought up eDNA data. Are there data that you could use strategically in whatever business you're in that wasn't mentioned? We should probably open a discussion on those data types to see if there isn't a match. Certainly, let's say atmospheric river data, which has a great deal to do with forecasting precipitation. That's Marty Ralph's area. There are, I'm thinking of Kim Prather with aerosols, and aerosol behavior. And, she's been super busy during the pandemic in both research and lecturing. Didn't talk about that in this webinar either. There are more data types than I can remember that probably provide data that would be useful to many organizations and people. So, if you're in the Q&A and there were data types that weren't mentioned, but they would be advantageous to you, please let us know. That would be very valuable information to have and a good way to start subsequent discussions.
Thanks, Steve. I'm happy to share the poll data while we're waiting for responses on that. Or
that'd be great.
Yeah. All right. And again, would love to hear for all of you that did fill out the poll, to Steve's point, what's your interest in these and data sets, and how would you envision applying them to your industry? So the most popular vote was Argo at 56% of the votes. Second up was Coastal Data Information Program, CDIP buoys at 53%. The next was the Pier Shore Station Program at 26%, and then the Keeling Curve at 21%. Was that where you thought would be aligned, Steve?
Yeah, it sounds about right. I mean, the two programs that I talked more about got more votes. So how many people, I'm interested to know how many people responded to get those percentages.
We had 77% of the attendees vote. So
wow,
that's pretty good.
Yeah, I would say that reflects actually what people are wanting to know. I did have another story. I didn't have a slide prepared for this because it was something that conversations I had throughout the 80s and 90s. I know that the Army Corps of Engineers took shore photography that was used by a few businesses. They took the photographs in the 80s, then the photographs were digitized by various businesses in the 90s. Those businesses ended up digitizing the photograph and became the source for these digitized imagery. And the Army Corps of Engineers became interested after industry was done using what was originally their photographs to do, shore erosion, to build piers and ports. So the arrow goes in both directions if there's a good communication tradition set up between industry and academic research.
Excellent. It looks like we got someone. Martha entered a question saying she's interested in the most updated bathymetry and sub-bottom data off San Diego for continued studies of offshore marine terraces at 16,000 to 6,000 years ago.
Oh, well, I don't have an instant answer. I know that NCEI does have bathymetry data, and then sub-bottom data off San Diego for the continued study of offshore marine terraces. Every time I think about bathymetry, I think of David Sandwell, and Smith and Sandwell's bathymetry. Boy, it's kind of unrivaled. That would be a great place to start. And I think that there may be a Smith and Sandwell link to their bathymetry on the Scripps webpage, their latest. Oh, and while you're at it, I think somebody asked about tools. GMT is a great toolkit to use to visualize all of these data. And I know they've gone from, geomagnetic data to atmospheric data to oceanographic data. GMT is kind of the move, and that's Paul Wessel out of University of Hawaii maintains that data set, or I'm sorry, that data set, that tool set. Generic mapping tools, GMT. Oh, there we are. There's a poll. That's good to know. Alrighty, Vanessa, the ball is in your court.
Thanks, Steve. And thanks everyone for such great questions and your participation in the poll and a great interactive discussion. This is really fun. I would encourage you highly to reach out to myself for any follow-on conversations or interest in connecting with researchers and different data sets at Scripps. I serve as a liaison, so I'm happy to help coordinate. And I will put my email address in the chat, but again, it's Vanessa Scott, so vscott@ucsd.edu. We have a lot of different ways that companies can collaborate with our community for research collaboration with our scientists, talent recruitment for our students, and just general visibility of what our new research initiatives are and updates. I will be sharing a webinar recording. It will be posted on our webinar website, which was in the chat. Romy, if you can put that, thank you. So yeah, Nathan, I would check that website. That's where we normally post them. And also stay tuned for upcoming webinars. We should be having some coming down the pike in the next few months. So, and also after this, there's a short survey. So let us know what you thought and any webinar topics that you're interested in learning about moving forward. So thank you again to our marketing partners for helping share this information and getting the invitation out to you guys. Thank you, Steve, for an awesome presentation, and Romy for your support. And we thank you all for joining us today, and we look forward to continuing the conversation. Thanks, guys.